All right, so I just wanted to fill out this table really quick. So there's a couple ways we can do it. If you remember your special right triangles, which I'll go ahead and actually I'll just draw them right here. So that would be 30, 60, 90 is one of them. And this one was X right there, X rad 3, and then this one was 2X. And then our other one was the 45, 45, 90. And so that one was X here, and X rad 2 there. So if you remember those, then that's great. You could use these. You could also use a calculator for these if you really wanted to. I'm going to go ahead and use the special right triangles here, though. So for the 30 degrees, I'm going to grab this one right here. And so I see that the sine would be, since this is opposite, and this is hypotenuse, right? And we got adjacent. So sine would be x over 2x, and so that would reduce to 1/2 because the x's would cancel out. So x over 2x would reduce to 1/2. And if I did cosine there, it'd be adjacent over hypotenuse. That would be x rad 3 over 2x. So the x's would cancel out again. So we would get rad 3 over 2. So if you type this in the calculator, then this one would probably be 0.5 right there. And then the cosine would probably be some decimal, right? It would be, I think it's like 0.77 or something like that. So that is equivalent to the rad 3 over 2. If you type that in, it's actually the same thing. And so then the tangent here would be x over x rad 3. So once again, the x's would cancel out. So it would be 1 over radical 3. And then the cosecant would be the reciprocal of sine, so that'd be 2 over 1, so just 2. The secant would be the reciprocal of cosine, so 2 over rad 3. And then cotangent would be the reciprocal of tangent, so that's radical 3 over 1, which I would just write as radical 3. All right, next up we have the 45-degree angle. So I can pick either one from this triangle. So if I go over there, that's opposite. Our hypotenuse is over here, and then this one's adjacent. So if I go opposite over hypotenuse, that would be 1 over radical 2. And if I did the cosine, it would actually be the same exact thing because it's still x over x rad 2, so that's 1 over radical 2. For tangent, it's x over x, so you can see here opposite over adjacent would be x over x, so anything divided by itself is obviously 1. And then the cosecant would be radical 2, would be the reciprocal of 1 over rad 2, and then the secant would be the same. And our cotangent, the reciprocal of 1, is actually 1. All right, so then lastly, we'll do our 60-degree angle. So now I'm moving back to this triangle, but going over here. So now this one is opposite, and this one is adjacent, but this one is still the hypotenuse, obviously. So our sine will be x rad 3 over 2x. The x's cancel out again, so that would just be rad 3 over 2. The cosine would be x over 2x, so the x's would cancel out and give us 1/2. And then the tangent would be opposite over adjacent, so x rad 3 over x, so that would be the x's canceling out and give me rad 3 over 1. Now what you'll notice here is that the 1/2 moves over here on this triangle, and the rad 3 over 2 moves over there. It's because we're kind of moving to the other angle, and so the sine and cosine kind of switch because the one that we were calling opposite is now adjacent and vice versa. All right, so now for the reciprocal functions here, we can just flip these guys over. So we get 2 over radical 3, we get 2 over 1, and we get 1 over radical 3. All right, next question we're going to do here is number 2. So they say this one is 34, and then C is 15. So they want me to find all the missing sides and angles. And so I'm going to go ahead and take my 34 here, and I'll label this one as opposite, label this one as the hypotenuse, and then I'll label this one as adjacent. So we know about the hypotenuse so far, so I'll go ahead and find B next. So that's the opposite side. So with opposite and hypotenuse, I'm going to use sine. So sine of 34 equals B over 15. So I'll multiply the 15 over to the other side, cancel that out, and we'll type that in the calculator here. So what is that? 15 sine 34 So that gives me b equals 8.4, we'll call it. It says round to the nearest tenth, so it's just one decimal place. Okay, so the next up, we'll do find a. So for a, that's we're going to use a cosine here. So cosine 34 equals adjacent, which is a, over hypotenuse, which we know is 15. So we'll multiply that 15 over, cancel that out. So now 15 times cosine of 34 will give us 12.4. And then we do need to find that other angle. We kind of forgot about that. We could have done it at the beginning, but it's fine. We can do it at the end now. So we got 180 total, minus the 90 for the right angle, minus the 34 for the other angle. So it sounds like 56 degrees to me. All right. All right, similar idea here on number 3. So for this one, they give us 42 degrees right here. They give us 13 over here for B. And so I'll go ahead and find that other angle here to start. So 180 minus 42 minus 90. And so that's going to be 48 degrees right there. All right. And from there, I'll go ahead and use the 42 though still. So I'll label this one as opposite. This one's the hypotenuse, and then we got our adjacent is B. We could have done this using 48 degrees. I just picked 42. So let's go ahead and find A next. That's our opposite. So we want to know opposite. We do know adjacent, so we can use tan for that. So tangent of 42 equals A over 13, which is our B value. So we'll multiply the 13 over the other side. So we just have A is 13 times tan 42. 13 tan 42, and that gives me 11.7. All right, and then we can go ahead and find the hypotenuse now. I'll go ahead and use cosine for this. You could use Pythagorean theorem if you wanted to, or even sine, but I'll just go ahead and use a cosine. So I have cosine of 42 is the adjacent 13 over C, since that's the hypotenuse. So we'll multiply the C over to the other side. And we'll divide by the cosine of 42, which means C equals 13 divided by cosine of 42. Making sure we're still in degree mode, and we are, so then my C value would be 17.5. Okay, number 8, kind of a tricky one here. So for this one, it says to estimate the height of a mountain above a level plain, the angle of elevation at the top of the mountain is measured to be 32 degrees. So we kind of have our mountain here, okay? So I'll just draw a rectangle and label it M for mountain. And it says the angle of elevation is 32 degrees. So remember, that's always created with a horizontal line that I just drew down here, and a diagonal line. And so that's 32 degrees right there. Try to write that a little bit neater. Okay, that'll have to do. So 32 degrees, okay. 1,000 feet closer to the mountain, it is found that the angle of elevation is 35 degrees. Okay, so we move a little bit closer here. And so now we're still doing an angle elevation to the top. It's now 35 degrees. And we know that we are 1,000 feet closer. Oh, that's a little typo there. That should say closer. Okay. So I'll label the 1,000. I'll label it right here. But we just need to make sure we know that it's kind of just from here to there is 1,000. Okay. So it says estimate the height of the mountain. Okay. So with this information, we are going to be able to estimate the height of the mountain. I'm going to call that X. It's going to be our ultimate goal. Actually, I'll just label it M. How about that? Since we already labeled it there, okay? Because I'm going to need another variable here. I'm going to need to use X right here, from here to here. And that's going to help me out on this one, okay? So this one's kind of really tricky, like I said, because we have so many unknowns here. If we knew this whole side length, that would make things a lot easier, but we don't. But the only thing I can kind of see here is that this all together would be X plus 100, or sorry, 1,000. So we have that kind of built into two pieces there. So I'm just going to build some trig functions here and kind of just see what happens. So I'm going to go ahead and use tangent on both of these because it looks like the hypotenuse I really don't know anything about here. So let's do a couple of tangents. So let's do tan 35 first. So tan 35 is going to be opposite, which is m, which is obviously unknown, over x, because you can see here on this kind of triangle right here, our opposite is the big M, and then the adjacent is just this piece right here, x. It's not the whole x plus 1,000 on this 35-degree angle here. It's just the x. Okay, so I'm going to leave that alone for right now. Not really sure what I'm going to do with it, but let me move now on to the 32 degrees. So let's do tan 32 now and see what that comes out to. So if we look at tan 32, the opposite side is still m, and the adjacent side, well, if we're looking at this whole triangle, the adjacent side is the whole x plus 1,000. On the right triangle here, 1,000 is not even on there. So the x plus 1,000 is that whole side length. So that's going to be my adjacent side. So I'm going to go m over x plus 1,000. Well, what I see here is I have two different equations with two variables, and with two different equations with two variables, we can actually always solve this by using systems of equations. So we can solve this by using elimination or substitution. So I think elimination, or sorry, not elimination. In this case, substitution is going to be a lot easier since these are kind of fractional variables here. So I think especially on this equation on the left, I can isolate the m pretty easily. So I'm going to go ahead and do that. So I'm going to multiply the x over to this side. So now I have that x times tan 35 equals m. So then I can use that to substitute over in this equation for m. So I'm going to say now, I'm going to put that right there, which is going to have me saying that tan 32 equals x times tan 35 over x plus 1,000. So I just, you can see substituted x tan 35 right there, rewrote that, everything else in that equation was the same. Since I have an x inside parentheses on this side and I have another x over here, I don't want this in parentheses, so I'm going to go ahead and distribute that tan 37. I'm actually just going to leave it as tan 37 though. So that's going to be x times tan 32 plus 1,000 times tan 32 equals x times tan 35. Okay, so now I see I have kind of two x's in unlike terms there and there. So whenever that happens, I need to get them on the same side and everything without it on the other side. So I'm not going to kind of show that, but I'll tell you what I'm going to do. I'm going to subtract that one that way, the 1,000 tan 32, and I'm going to subtract the x tan 35 that way. So my next line is going to be this x times tan 32 that I'm not moving minus x times tan 35 equals, and then I'm moving this one over as a negative 1,000 tan 32 since I subtracted that over. Okay, I'm going to need some more space. Apologize for that. So you guys can move down here. I'm going to put a box over this number 9. Hopefully, maybe you wrote smaller than me. So there we go. Okay, so now what I'm going to do is I'm going to factor out the x here. And then I can write this as tan 32 minus tan 35. All right, you are not allowed to combine these kind of in any way in here. It's not going to be like tan negative 3 or anything like that, tan of 3. You just can't combine anything, the different tangents there. So what I am going to do is I'm just going to divide that over. So tan 32 minus tan 35 over to the other side. It's actually going to give me my my answer for x here. It's actually not going to be my final answer, but it is my answer for x. So we'll cross that off. Let's type this into the calculator here. So negative 1000 tan 32 divided by tan 32 minus tan 35. And that's going to give me x equals 8294.2, we'll call it. All right, so then let's remember that we were actually trying to find the height of the mountain here. So this is what we labeled as m. So to find m, which is, if we think back here to our original two tangent equations, I can plug in this x value now into either one of them, which either one looks easier. This one looks a little bit easier to me. So that is going to say that, let's see, or actually even easier, I can plug it into this purple one. This one right here, x tan 35 equals m, right? Because that way we can just, it's already solved for me. So m equals 8294.2 times tan 35. So that'll give me my final answer here, which will be 5807.7 feet. So pretty cool there. If you kind of think back to what we actually did, is we were able to kind of calculate the height of a mountain by just kind of measuring an angle here, walking 1,000 feet forward, and then measuring an angle there. They do actually have, they have apps actually that you can aim it at the top of an object and calculate that angle of elevation. So if you ever like to do something like this, now you know how. All right, next up here, we're going to go over a concept that's actually, it's not in our textbook, but I see it all the time on the SAT and the ACT. So if you're prepping for either one of those, it's probably a good thing for you to know. And the topic here is called trig functions of complementary angles. So to kind of explain this conceptually here, let's fill out the missing angle in terms of alpha. So if we think about the right triangle as a whole, kind of like we usually do this, right? So I know it's 180 degrees total. I'll do this in green here. So we have 180 degrees total. We know that the 90 degrees is the right angle, and then the other angle is A. And so if I simplify this, I would say that this one is 90 minus A degrees, if we're using degrees here, of course. And so what we're kind of trying to get across here is that since these two always add up to 90, these are actually always complementary angles. And so if we think about this, the sine of this one, well, the sine of alpha would be, so now for the sine of alpha and the cosine of alpha, I'd have to kind of make up some sides here. So let's go ahead and call this x, y, and z. And so the sine of alpha would be opposite over hypotenuse. That would be y over z. And then the cosine of alpha would be adjacent over hypotenuse. So that'd be y over z. But what I then wanted to look at was, what about if we did sine of 90 minus alpha? What if we did sine of the other angle? It's already labeled right here, so this should be pretty easy for us to do. And you can see that that is opposite over hypotenuse would be x over z. And if I asked about cosine of the other angle, the 90 minus alpha, that would be y over z, adjacent over hypotenuse. So what we see here, and this is kind of the big formula, is the cosine matches up with the sine over here, and the sine matches up with the cosine. So we can always say that sine of any angle, which I'll now call theta, we could call it alpha, is equal to cosine of 90 minus that angle. And then on the other hand, cosine of any angle is equal to sine of 90 minus that angle. So it's a good kind of formula, like I said, that they use sometimes on the SAT, and how they ask it is on questions like I've put here. So they'll say something like this. So sine of x plus 20 equals cosine of x. What's the value of x? So what you want to do on this is you want to switch one of these two to the other one. We want to kind of compare apples to apples. I don't want to compare a sine to a cosine. I want to compare either sine to sine or cosine to cosine. I'll go ahead and switch, why don't I switch this one here? So I know I can switch that to cosine of 90 minus x then, according to my formula. Oh no, I'd have to change it to sine, excuse me. I can change that to sine of 90 minus x here, because we know the cosine of one angle is equal to the sine of 90 minus that angle. I'm going to keep the left one the same. So I'm going to say sine of x plus 20. Well, those two then need to be equal, right? So if those are equal, well, I know sine is equal to sine, so now all I need to do is set the insides equal. So now I just need to solve this. I have variables on both sides, so I would just add this x over here, and I would subtract the 20. So I'm going to say 2x equals 70. So then if I divide by 2, then x must be 35. So same idea here. I can switch either one of these two. So I can switch the sine to a cosine or the cosine to a sine. I usually do the one that's simpler. So I'll go ahead and switch this one then to cosine of 90 minus whatever was in there, right? Now, in this case, it's a little more complicated because we had x minus 3 in there. I have to put x minus 3 in brackets because it should be subtracting that whole thing, which means I'm going to have to distribute that. I'm going to keep this one the same because I already got the other one to cosine. So we don't want to switch both of them usually. We're going to switch one or the other. And it's kind of your choice. So now I'm going to distribute this. So I have cosine of 90 minus x plus 3 equals cosine of 2x plus 6. So now I'm able to just get rid of those cosines and set the insides equal. I'm going to go ahead and simplify this one to negative x plus 93 equals 2x plus 6. So I would subtract the 3x over here. No, sorry, subtract the 2x. It's going to become 3x. And then subtract the 93 over here. So that would give me negative 3x equals, so positive 6 minus 93, that's got to be negative 87. Yep, that is right. So then divide by negative 3. And what is 87 divided by 3? So 29. There we go. All right, so another similar one right here. So I'm just going to switch one of these. So I'm going to say sine of 90 minus bracket 3x plus 5 equals, oh wait, but I did 90 minus. So if you do 90 minus, you switch it to the other function. So I'm going to go to cosine here. And that's going to equal cosine of 4x plus 1. That one I'm not changing. Okay, so now I can set the insides equal. I'll go ahead and distribute my negative. So I'll say 90 minus 3x minus 5 equals 4x plus 1. So I'll send my 4x over here. So then I have, let's see, negative 7x plus 85 equals 1. So I'll subtract the 85. So it's going to be negative 84 equals negative 7x, which means x equals, if we divide by negative 7, that's 12. All right, next up, number 13 here, we're going to get a little more complicated because now you can see we're talking about radians here, not degrees. And so the only kind of thing you need to think about here is if I'm going to change this one to cosine of something minus pi over 5, it's actually not 90 minus pi over 5 because we got to be talking radians, right? So if we're talking radians, what's the same as 90 radians? It is half of 180, so half a pi, or pi over 2. So that's kind of the only difference. On the SAT, it's actually unlikely they would use radians, but you know, it's still kind of fun exercise to think about. Okay, so I can actually just kind of think about common. I'm going to drop the cosine since I got them the same. I'm going to start thinking about common denominator here, so I can make these both a 10. So 5 pi over 10 minus 2 pi over 10 is going to equal k, which means 3 pi over 10 equals k.